Assalamualaikum and good day all. Today I would like to explain about chapter 2 of fundamental hatchback, and the code of subject is BMMH 2503. Yeah. Okay, today we are already in the third week. Should be follow in the teaching plan. Should be in the chapter 2. Okay. What we learn in the chapter 2 is refrigeration cycle. So we try to learn in deep more in the cycle system of refrigeration. And then before that, I would like to introduce first what component or device that involving in the one system of refrigeration system. Okay, actually, refrigeration system is the science of producing and maintaining temperature below that of the surrounding atmosphere. And this means the removal of heat from a substance to be cooled. So actually, the refrigeration system is not only talking about the aircon system, or air conditioning system, but also in the refrigerator system that commonly used uh, in the home or the residence uh, living. So refrigeration will involve to type uh, both in the air conditioning system and the refrigerator system. But before that, how refrigeration system used in the before in the modern application. What they do is they to cool a warm object before refrigeration was invented, human placed material to be cooled near a cold object like a block of natural ice or in the cool well, pond or lake. So they bring the cool ice block in a certain container, and then they keep it inside there with the product, food product, for example, to be maintained in the quality. So they put together with the ice block. Yeah? And then I try to separate it within the air conditioning refrigeration. So the air conditioning system will cover by heating, humidifying, and control of air quality. Uh, Beside that, refrigeration system is used in industrial refrigeration, including the chemical and process industries, food preservation. So, uh, both of these conditions have one part uh, that we linking within the air conditioning and the refrigeration. That more on the cooling system and the dehumidifying system in the conditioning system. So even different the application, but the basically have the similar of the system, cooling and the dehumidifying. Sorry. So major uses is the air conditioning, application of the refrigeration system is in the air conditioning, food storage and distribution, food processing, chemical and process industries, petroleum, petrochemical, in the oil and gas application of the refrigeration. In petroleum, we use to freeze the gas to change the phase the gas into the liquid by reduce the temperature. from the normal room temperature into the negative 150 degrees Celsius. So we become gas into the liquid system. And the other special application maybe in the hospital, in medical system, anything, and maybe in the computing system. So we call that in the special application. A specific application, air conditioning of medium size and large building. Uh, So industrial air conditioning, we can separate in the several application, like the spot heating and cooling, environmental laboratories, printing, textile. So industrial air conditioning, we will divide by certain part. This part will be implement different condition. So sometimes need more is reduce in the temperature but low humidify. Other part we don't need the low temperature, but we need in the maybe in the 40 to the 60 of humidifying. Yeah. Sometimes we don't need, so depend on the uh, application we use. Even this refrigeration system considered in one building part, but we separate in the several room, so with the certain condition like spot heating and cooling, environmental laboratory, printing, textile, maybe like a computer room. Same like our campus, we also implement this condition. Depend on the application inside with maybe need a specific application. And then special application or refrigeration, like drinking one time, dehumidifiers, ice maker, ice skating ring, construction, desalting of seawater. So sometimes uh, in the pleasure need, like the sport, we also have refrigeration system like ice skating, and then in other part like the ice maker, maybe industry in the ice cream, produce ice cream, or with the uh, milk base. Anything we need the refrigeration interns to keep the quality in the product. And then not also in the food storage, in the engineering, other engineering like construction refrigeration also we need. So where is the application? Refrigeration is called, sometimes is used the free soil to facilitate excavation. Excavation is a need to drill, but before that we treat by the freeze the soil. Then easy to drill to make the excavation. The further use of refrigeration is need a cooling huge masses of concrete. The chemical reaction which occur during the hardening gives off heat which must be removed so that it cannot cause expansion and stress to the concrete. So we'll keep the uh, concrete in certain temperature by maybe we try to maintain the temperature without the expansion. We still need to cure the concrete, so we'll keep the size of the concrete, because we know by the every material, if we treat by higher the temperature, will expand the size or the volume. So in this refrigeration, we try to keep with low temperature to keep the volume in the without the expansion condition. Concrete may be cooled by chilling the sand, gravel, water, and cement before mixing, and by embedding chilled water pipes in the concrete. So even uh, before the concrete curing, we can do the treat by the uh, by temperature, low temperature, uh, to uh, to keep the volume is low. Then when we filling in a certain part, we have the mass with high density. As we know, if you concrete have the high density, will give the good mechanical performance. Okay, this one is a type of the concrete cooling system, as I mentioned before. So how the chilling system to keep the, in the quality of cement product. Okay, in the air conditioning itself, so actually divided by two types. First type of air conditioning is non-ducted product. As we know, a non-ducted product is not involved the piping, duct system. It means when the supply of the air conditioning to the every part or room without develop or create the ducting design. Another part, we need the duct system, or we call duct table system. This one, when we design in the big building, we need to design the supply to every room is by duct system. Okay, in under non-ducted product, we have two type of the air conditioning. The first one is the split air conditioning, and then the second one is window air conditioning. I think the new one is the split air conditioning. Maybe we don't have, or the industry don't have a new product in the window air conditioning, because last time we use the window air conditioning because we use one motor to move two device in the air conditioning. What we use one motor to activate. The first one is condenser and also evaporator. So this one I make one uh, maybe one system, only in the one compact system of window air conditioning. But now we split within the condenser and evaporator. Okay, so that's why we call the split air conditioning. So other part, the evaporator, we put in the inside of the building, and the other part is condenser. We put in the outside of the building. So that's why we call the split air conditioning. In the split air conditioning, we can design if whether using the floor mounted, we just put in the low level of the uh, evaporator. Uh, some we put in the ceiling, we call the ceiling mounted, and then some we just attach in the wall, so we call the wall mounted. So the split air conditioning we can divide by condition of the evaporator position. And then under the split air conditioning also we can divided by three types: exposed type, hide away type, and cassette type. And under the data table system, also we can spread by package air conditioning, central plant. So this one depend on the size of building we design, and then the building needed. Maybe we need the package air conditioning or central plant only is enough. Okay, depend on our design. So under this package in the HUD or the huge building, big building, we can use this application duct table system. So we can see, we can choose based on the needed. So what the parameter we need is already put in the flowchart, this flowchart. So we can refer anytime from this flowchart to our designing. Okay, vapor compression refrigeration system or reverse Carnot cycle. So actually, in theoretical, in the thermodynamic theoretical, we implement the reverse Carnot cycle. So actually, they have four cycle in basically that follow the Carnot cycle law. So the first one is working substance, hot reservoir, heat source, cold reservoir, heat sink, so engine heat pump. So today, hot reservoir we will release into the environment, and cold reservoir will release to the rooms based on the application. Sometimes in the winter we need the hot reservoir, but so it means we utilize the hot temperature to our room. But if we in the summer or the climate in the Malaysia climate, so maybe we will utilize in the cold reservoir. Okay, this one is schematic of heat engine. Heat engine in the refrigeration system is actually we focus in the pump system. So pump system in the refrigeration system will produce the hot uh, produce hot temperature to produce because the activity of the heat engine is fully with the wear and the mechanical work. So we produce the heat engine. We call it engine. So from the QH produce to low temperature. So we activate the pump. Pump will produce the hot or heat thermal, and then from this condition will produce the low temperature into the evaporator. So vapor compressor cycle, actually basically we have four components to produce refrigeration system. The first one maybe condenser, and then compressor, expansion valve, and the evaporator. Okay, the link within the device you can see from the figure. So we just follow the arrow, the direction of the flow fluid will go to in one cycle system, and then back again, and then will be a cycle and continuing. Okay, this one the basic part of the vapor compression cycle. As I mentioned before, we have compressor, condenser, evaporator, expansion valve. So we will learn what the what the part work do. Okay, every part. So we can see, we can check from here, from the slide mentioned about compressor. So the first part of compressor is a machine used to for increasing the pressure of gas or vapor. So the compressor will be produce of gas. So actually compress, transport from the low pressure into the high pressure to produce different pressure. So the flow will be work because of this differentiate. The compressor does work on the system, increasing the pressure from the existing evaporator into that existing in the condenser. So by produce differentiate of the compressor will be produce the flow. And then condenser a heat transfer device that reduce the thermodynamic fluid from its vapor phase to its liquid phase. So after compressor produce the heat, so from the liquid will be changed to the gas phase. So that's why we need the one part to change again the phase from the gas into the liquid by using the condenser. So the high pressure, high temperature vapor that enter the condenser has heat removed from it, and as a result is condensed back in liquid phase. It is where the refrigerant is liquefied and discharged its heat to the environment. So what happened? The temperature will be released to a reservoir. This means like the waste of heat into the environment. So by release the heat, now the refrigerant will be back into the liquid system by low of temperature. Now I show you maybe several types of the evaporator, sorry, condenser. Condenser. Same like the condenser actually, evaporators, but the difference is the application to reduce the heat. We use fan, but maybe several type. Some we use the fan to force the air through the fin, and then some we don't need the fan, only use environment temperature. But these two types have benefit, maybe, and then maybe have the what drawback, maybe. And then other parts of refrigeration is evaporator. So what the function of evaporator? Any of many devices in which liquid is changed to the vapor state by the addition of heat. For example, distiller, still dryer, water purifier, or refrigeration system element where evaporation proceeds at low pressure and consequent low temperature. Heat is absorbed to boil the liquid at a low temperature. Therefore, a low temperature must be maintained in this section. So what happened in this part? So with the refrigerant in low temperature, and then release the temperature to the several part of the room to reduce the room temperature by release the air through the fin, because the tube will be flow inside of the low temperature of the refrigerant. So we just need the fan to push force the air to within the fin. So what happened? So this air will be bring together with low temperature to the room. If we need this one to the room, so maybe to the room. If this one is a refrigerator system, it's made in the container system of refrigerator. Sorry. So other part in the refrigeration system is as a throttle valve, or sometimes we call expansion valve. So choking device to regulate the flow of liquid, for example, in a pipeline to an engine or to turbine from a pump or compressor. The high pressure liquid from the condenser is expanded to this valve, allowing this pressure to drop to the existing in the evaporator. So actually, what the throttle valve do is just reduce the pressure from the higher into the lower. As we know, if one liquid we reduce the pressure in the automatically we will reduce the temperature together. So how we reduce the pressure? So the valve with the high pressure inside from the evaporator system into the valve, and they will spray in the system of valve spray by reducing the pressure. So automatically will reduce the temperature. So this one cycle system of refrigeration system. So we go first from the pump or compressor here, and then we go to the condenser to reduce the temperature, and then after that we reduce the condenser temperature from the condenser. Then we use this low temperature to the utilize in the several application, for example, refrigerator, air conditioning system. Okay, and then after that, from this evaporator, we have maybe 5 degrees Celsius or more than 5 degrees Celsius different, and then we produce maybe higher temperature compared to before inlet in the evaporator. So after that, the pump will be released again into the condenser. Okay, in the lab actually, we will conduct the lab in one cycle of refrigeration system. In the actual setup is like this actually. So actually, if you have time to visit the lab, so we will see this setup of aircon system or HVAC system in one cycle Carnot system. This one is the compressor, evaporator, air condenser, and then the evaporator. This one is the valve, expansion valve to reduce the pressure. Okay. Same thing if we implement in the refrigerator system. So the hot part will be put in the back of the refrigerator. So we will feel the hot temperature from the back of the refrigerator. So actually, we have one agent to transfer the temperature from low to high, high to low. So we need one agent. So what agent this one is we call refrigerant. So we need refrigerant to make to activate the refrigeration system. If we don't have refrigerant system, we don't have the agent or medium to transfer the temperature from high to low, low to high. So actually, the first refrigeration system is using the water in the last maybe last decade before modern of refrigeration system. But now we still use in the water system, but maybe in several application only. Maybe in the EU building, we still use the water as a refrigerant. But in the small type of refrigeration system, we use the other agent. The substance used for heat transfer in the refrigerating system, it pick up heat by evaporating at a low temperature and pressure and gives up this heat by condensing at a higher temperature and pressure. So sometimes we use the first agent. We use freon. So what is the freon? It's a group organic compound used as a refrigerant. Freon is DuPont trade name for its chlorofluorocarbon and hydrofluorocarbon refrigerant. It's used in the air conditioning and refrigeration system. Its brand name DuPont refrigerant. Now in the common use in certain application of refrigerant, we use the freon. DuPont pioneered much of the science and make air conditioning and refrigeration possible. With over 75 years of global leadership in the refrigerant science and technology, we offer the broadest range of refrigerant solution for new and existing equipment. And we are committed to leveraging the science of cool to lead the search for new cooling solution that improve comfort and change the quality of life around the world. So really the DuPont have what we call have the effort in the using the agent to produce introduce the agent of the refrigerant. History of freon, you can see here refrigerators from late 118 from the century, 18th century until to 19. Use the toxic gases ammonia, methyl chloride, and sulfur dioxide as refrigerant. Okay, you can see by yourself here the history of freon. And Thomas Megley Jr., headed by Charles Franklin Kettering, invented miracle compound called freon. After that, CFC. Now we don't use anymore of CFC. So, in the principle of the refrigeration, we will use the power by call it the ton, 1 ton of refrigeration. So what do you mean the 1 ton? The American Society of Heating, Refrigerating and Air Conditioning engineer is the transfer of 200 British thermal unit per minute or 12,000 British thermal unit per hour is the basis of refrigeration calculation, whether for cold storage, air conditioning, ice making, or ice cream manufacture. So actually, we will use 1 ton term to explain the power of the refrigeration system. If you was some mention about 1 ton, it's mean similar to 200 British thermal unit per minute. It's mean the same number. If someone mentioned about 1 ton. Okay, that's all for today in chapter 2 on third weeks. Yeah. So I hope you can answer the question for weeks, third weeks, for your consider as your attendant. So I will put. Please check your ULearn in the ULearn the task I will uh, conduct in the third week. So if you fulfill the task inside of the ULearn, so I will consider you watch the video. Okay, thank you for today and see you next week in the next subtopic in our subject. Okay, Assalamualaikum and good day all.